Hello, everyone. Welcome back to this class. So now we're going to talk about section 2.2, histograms. So the histogram is a graph that displays the data by using continuous vertical bars unless the frequency of a class is zero of various heights to represent the frequencies of the classes. So one thing to mention for the histogram is histogram must match your frequency distribution. So the correct order gonna be you're first gonna even though your initial goal is to generate a histogram, but the correct order gonna be if you want to generate one, you first need to make a frequency distribution. Based on that frequency distribution, you're gonna draw a histogram. Specifically, histogram is for quantitative data. So now let's look at an example. So for this number of TV data, we have all the classes from 0 to 6 and the frequencies. So what we need to do is we're going to place 0, 1 up to 6 in the middle of each bar and represent that whole class. And then use frequencies as the bar head. And then note the bars stays together. So let's go back to these frequencies. We have 1, 16, 14, 12, 3, 2, 2. Then from the histogram height, you should still have the same thing. So we have 1, 16, 14, 12, 3, 2, 2. So exact match. So this is called the frequency histogram. And also we can generate a relative frequency histogram, or we just call it by percent. So we have 2%, 32%, and 28%, so on and so forth. So now the relative frequency or the bar height represent the percentage, or then you just need to just find the reasonable height for that percent. So 0.02, 2%. So it's a little below this midpoint between 0 to 0.05 because that's 0.025. And then this is in between of 30% and 35%. Indeed, it's 32% and so on and so forth. So now we can successfully generate the relative frequency histogram. Another thing to mention is the overall shape. So if you look at the frequency, we put a smooth curve on top and another smooth curve on top. They're pretty much similar to each other, although the scale might not be exact same, but no matter which one you use, frequency or relative frequency, you should get a similar shape of the histogram. And now let's look at the cut point grouping method one. So weights of 13 males. We have frequencies at 6511. Then the frequency bar hat gonna be 6511. And then again, percent is the same as relative frequency. So similar shape, no problem. And now let's look at the horizontal or axis. The horizontal scale, each bar represent a class because this is cut point grouping method. So we're gonna just put down all the cut points. So 129.2 is one cut point, the smallest one. So the first class is 129.2 to 169.2. So we put that here because the bar stays together. So from 169.2 to 209.2, and then so on and so forth until we successfully specify all the cut points. So if we go back to that frequency distribution, the cut points is actually the first class plus all the upper class limit. And then that's all for section 2.2. Now let's look at some other types of graphs. So now let's recall this data set is the relative frequency distribution for the party affiliation data. So is a qualitative one. so qualitative one. And then what kind of graph we can have for qualitative frequency distribution. So the first one we want to introduce is bar chart. This one is very similar to the histogram, but since it is for qualitative distribution, the bars, they do not stay together. You got a gap between the categories, meaning that they're qualitative. And then for relative frequency distribution, same thing, the height represent the percent. So if you look at the data, we have 32.5, 45, and 22.5%. So those are exactly match. So again, this is for qualitative data, and then bar chart. And the next one, pie chart. Actually, I think a lot of you already know how to draw a pie chart. Just a circle based on areas. We're going to separate the percentage and represent each categories. So the higher the percentage, the larger the area is. That's a pie chart. And now let's look at the pad example. So if we go back, we're just gonna copy this result. So we have 2, 17, 6, 1, 4, 30. Relative frequency is 2 divided by 30. So we're going to calculate this as a percentage. 2 divided by 30, that's 6.67%. 17 divided by 30, that's 5.67%. 6 divided by 30, that's 20. 6 divided by 30. So for this one, it's not correct. That's 56.67%. And then that's 20%. And 1 divided by 30, 3.33%. And last one, 4 divided by 30, that's 13. Add up together should be 100%. Now we want to draw a pie chart and a bar chart. So let's do the bar chart first. We're going to draw a horizontal scale, and then this is the frequency. So for the pie chart, first let's draw a frequency one. So we have, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think we have to redo it. So 2, 4, 6, 8, 10, 12, 14, 16, 18. That's the frequency. And then for the bar, we have no. So a height of 2. So this is the first bar. And then we have dog 17. We have cat 6. Note that the height is same as the frequency. 6, and then ferret 1. and then other 4. Okay, so that's everything. So this is the pie chart, the bar chart, and then now let's draw the pie chart. So a circle, and then if we draw half, that's 50%. But for dog, it's a little over that. So this area is for dog, 56%. And then the next biggest one is 20%, about 1/5 of the entire one. So we say this is for cat. And then other is likely smaller than this one, 13%. And then we have 6%, and then 3%. So probably a little larger. Cat. And this is other. And then no. Last one is family. So, now we're going to introduce another one called dot plot. Dot plot is similar to the bar chart. As long as you see the value, you just put a dot on the horizontal, on top of the horizontal numerical scale. So let's say for example 210, so you just put it here. If you see another 210, just put it a little higher. So these dots gonna show you the basic shape of the distribution. So we can put a smooth curve on top of this one. So this is basically the shape of the data set. And the next one, stem leaf plot, which is very important. In a stem leaf plot, each observation is separated into 2 parts. A stem, which consisting of all but the rightmost digit, and a leaf, which is the rightmost digit. So let's look at a data set. So for this one, we have 2-digit numbers, 70, 64, 99. So the rightmost digit is gonna be for the unit 1, right here. We're gonna put all these into the leaf, and then the rest, the 10th unit, we're gonna have those in the stem. So now we just need to check the lowest number, lowest level. So we have 30 something. So then the stem starts from 30, and 40 something, 50 something, 60 something, 70 something, 80 something, and 90 level. So now we're gonna just put each one in the correct position. So 0. For the 70 level, we have a 0. Then just put a 0 there. And then we have 62. Then 60 level, we put a 2 here, so on and so forth. You're gonna have all the value stored in the leaf part. Also note that if you count the leaf part, how many values you have there? You have 40 values there. Then that represents you have 40 observations in your data set. And then this is not done yet. We have to order the leaves to just make it clearer, the stem leaf plot. So we always start with the smallest, which is 36, and then the largest we can read as 99. So this is another way to store your data set. So completely stored, because based on the stem leaf plot, you can write back to the raw data set. Based on the raw data set, you can generate the stem leaf plot. And then this can tell you the shape of the data as well. Just put a smooth curve on top, and then you can see the shape. This is the shape. Now let's do another practice problem. Cholesterol levels for 20 high-level patients. So we have 20 numbers here, and then now we want to draw a stem and leaf plot. So now still the rightmost digit, the rightmost value is for the unit position. So all these, we're gonna treat all those as the leaf part, and then the rest of the values that's gonna be stored in stem. So we have 19 something, 20 something, and then 21, 22. That's it, 4 levels, and so we all know how to do it. So just look at each number and then put in the leaf, and then generate the stem leaf plot. So this is A is a correct one, but it's only one line per stem. It caused some problem because if we draw a shape of the data, it's very steep. If we want to spread out a little bit and then just for us to interpret the data set easier, then we're going to do a 2-line per stem. So we got 19, 2 19s, 2 20s, 2 21s, and 2 22s. So this level is actually for the number from 0 to 4. And then this second line, that's from 5 to 9. So you have 5. So 0, 1, 2, 3, 4, that's 5 numbers. 5, 6, 7, 8, 9, that's 5 numbers. So it's equally distributed. But another thing to mention is after you got your stem ready, just try to put the leaves in. But for 19 lower level and 22 upper level, you don't have any input. Do you need to still include that there? The answer is yes, because you want it to be equally likely. If you have 2 levels for each one, then you just want to remain everything the same. Although there's no input, just make it empty. And then now we finished section 2.3. Section 2.4, we're going to talk about distribution shapes. What is a distribution? A distribution is a table, graph, or formula that provides the value of the observation and how often they occur. So this is a concept. We're going to talk about this in chapter 5, I believe. Chapter 5. So some mathematics, statistic topics. So right here, we're focused more. We're currently focused more on the shape. So to describe a shape, we did this already. Just put a smooth curve on top of it to look at the data set. So based on the peaks, so this is just one peak, and then this one has 2 peaks and then multiple peaks. So based on the peaks, we say the distribution is unimodal, bimodal, or multimodal. And then based on whether the distribution is symmetric, we gonna look at the symmetry and then the skewness. So now let's look at the symmetry distribution first. So the bell-shaped distribution is a symmetric distribution. That means if you draw a line here and then flip it, you got exact same distribution or curve. For triangle, same thing, and then uniform, same thing. And then this bell shape, later we'll learn it. It is also called normal distribution. Very, very important distribution. And then now let's look at the skewness. So the skewed distribution, we have 2 types, right skewed and left skewed. So when a shape of a data set looks like A, so a majority of the group lies towards to the left, and then only leave some unusual large number to the right end, and we call it right skewed. Same thing, if long left tails, that's left. And then a special one, we call this reverse J-shaped distribution. It's more like approaching down to the horizontal line. After we discuss the shape, now we're going to look at one more thing, the population distribution and 6 sample distribution for household size. So this is the population distribution. Now we can just put a smooth curve on top, and then we can do all for the samples. So now what we can get, the sample distribution shape is very similar to the population one, and that tells us for inferential statistics, it is reasonable to use the sample statistic to approach the population parameter. Okay, and that's all for this chapter, chapter 2. Don't forget, worksheet 2 has already been posted, and then again, look at the due date for worksheet 2 and then submit it through the Blackboard online system. And thank you.